Alright, so I want you to go ahead and start on this one. So right now, there are 3 questions on there, if I'm not mistaken. You all are going to have about 10 minutes. We're on a roll.
Plus 1, and times 2, and times 2, and then it's up to 2. For number 2. For the second option, we just found it at 1,000 times 2.
All right, so look at number 1. Number 1 is a graph of a function. Okay, and it says to find the average rate of change between x equals 1 and x equals 4. Okay, since we have a graph, we don't have an equation that we can plug these values into to get the y that belong with it. But we do have a graph where we can find the y coordinate for each x. Right? So if we look at the graph on your paper, what is the y coordinate that goes with 1 for x?
3.
And what is the y coordinate that goes with 4? Has everybody located those 2 points? Okay. So now I have my first x, my first y, my second x, and my second y. You can label them that way. Okay? But what is the formula that we use for average rate of change?
Minus y over x2 minus x.
What is it?
y2 minus y1
Finish
over
this.
x2 minus y. I mean x1.
X1. Okay, so I heard somebody else say a different version.
Isn't it
B
the
minus f of a over
Very good. So this was the formula that I first gave, and it kind of looked funky because we didn't really know what the f of b was and the f of a was. But we took it and related it to a line and found the slope. And then we realized that the slope formula was the same thing as the average rate of change formula. Okay? So when we have these points like this that are labeled x1, x2, and so forth, it's easy to plug it in. So what do we get when we plug it in? So what was y2?
0?
Okay. And what is y1?
3.
And then on the bottom we have, and what did that give you? Which is -1. Okay. It is very important that you label these points because then it helps you if you start here for y2, you need to start at the same point for x2 instead of going in between the 2 points. Any questions about this? There was a problem where it test very similar to this one. Okay, so look at number 2. That's probably the one that you're most familiar with because when I introduced average rate of change, it looked like this, right? We had the equation and we did something to it. Okay, so we have the function and we want to find the average rate of change between 0 and 3. So what do?
We plug in 3 and 0 into the formula.
Okay. Okay, so we have 0 and 3, we have our formula. So which part of the formula, do you want to use this version or do you want to use this version?
The second version.
First.
Second.
Why do you want to use the first? You said the first. Why would you like to use the first?
They didn't look the same.
They are the same, but sometimes it's easier to use one when you have one representation, and it's easier to use the other when you have a different representation.
But for that one, I would say I would use the one on the right.
This one?
Yeah.
Yeah. I would agree. I think it's easier to use this one as well because we can easily label these A and B, right? So, which one is A?
0.
And then this one is B. So, we have the A and B that go at the bottom. Now we just have to find F of B and F of A. So, or in this case, H of B and H of A. So what is F of B?
That would
How do
be
you find it?
16. Oh,
3.
it's 16.
That's what,
You
yeah.
plug in 3 and you get 16.
You plug in 3 into what?
Two parentheses, x minus 1, close parentheses, to the third power.
Okay, so that was the function, right?
Mm-hmm.
Okay, so then, Deeper, you told me I plug in
3.
3, because 3 is B. All right. So if we plug in the 3, what do we get?
16.
And this is what I mean when I say show your work. This is what I want to see. On the graph, I don't want to see that you drew a line between the 2 points and just count it by as every run. I want to see the work in the formula. So if we have F of B, how do we get F of A?
Same thing.
Same thing, except we're going to use what?
0.
0. And what does that give? -2. So now we have all 4 pieces, right? So we can come over to our formula and just put them in here. So what do we have?
16 minus -2 over 3 minus 0.
Notice these 2 negatives here.
So should you
Add
plus constant?
Exactly. So what do we get on the top?
18 over 3.
18 over 3, which is what?
6.
6. Very good. Any questions about this one? Yeah.
Well, you got 3 minus 0 again.
3 minus 0 is B and A, which were basically kind of given to us in this case. Okay. All right. So the last one is has a table. And it's got all this information about that. So, what do you think would be the points that we would use from this table?
30 and 20.
Okay, are those, is that a point or is that part of the point?
Yeah, it's like X.
Okay, so it's like, each of those is like an X, right?
Yeah.
Okay, so it's part of the point, so we don't know what the Y is yet, I haven't asked for that. Okay, so those are X's. Because everything in that row, in that temperature row, is considered an X. Everything in the metabolic rate is considered a Y. So what are the Y coordinates that go with this?
19.0. 6.0.
19.0, what else? 96.0. So now, even though this is a table, it kind of looks like the way we set up the first one with the graph. We have 2 points that we can label x1, y1, x2, y2, right? So now I ask you, which version of this formula is easier to use in this case?
The first one.
The first one, because we have x's and y's. So when we plug this in, what do we get?
96 minus, wait, yeah, 96 minus 20.
Minus
19.
Minus 19?
Mm-hmm.
Okay.
Over 30 minus 20.
30 minus 20, and then what do you get?
77, 19.
Can that get any smaller?
No, because it's
It'll be an estimate.
a 7.7.
So with average rate of change, we want to leave them in
Correct.
fraction form. Try to reduce it if you can, but this one's not reducible. So the answer is just 77 over 10. So now you've seen 3 ways that average rate of change can be displayed. Table, graph, and with.
Thank you, Ms. McLaughlin, for doing the warm-up and handling the rate of change. Class, today we are going to tie some things in with what your warm-up dealt with, which was rate of change. And we are going to look at some things about your exponential functions. We've been working on exponential functions, and we're going to be working on them for probably 2 more days. Today, and for the unit, you remember that we've been working on the parts of an exponential function and how they're interpreted in the context of the question. But today specifically, what you are supposed to be walking out of here understanding and knowing is how to identify specific functions given their graphing equation with the table of values and verbal descriptions, mainly the exponential. We're also supposed to look at some of the characteristics within the next 2 days about the domain and range. And then we're going to work on interpreting the parts of the exponential function, which is based on the main equation, y equals a times b to the x power. Remember that these lessons are supposed to be tied in with the Common Core, and you're supposed to know exactly which standards we're going to be working on, and that we're always supposed to be using these mathematical practices. So today, you need to make sure that you are looking at the interpretation of the function as far as the exponential is concerned. And we'd like to compare and contrast it with the linear and the quadratic function. We may get to quadratic, we may not, but we're definitely going to compare your exponential to your linear functions. So I need you to be thinking in that mindset. Okay. So, does anybody remember what you all have been working on the last couple of days? What's the topic? Exponential and logarithmic functions? Yeah, functions. That means. All right. Well, in order for us to be able to understand exactly what happens with these exponential functions, at least the exponentials, we are going to model some behavior so that you can see some real life stuff. And I'm going to ask you a question that is pretty much in your area as far as what you kind of want to grow up and do. You want to have some money. Yes? Yes? Yes or no? No? Yeah? How much money do you want to make, Rosie? You got to speak up. You don't know? How much money do you want to make?
At least 50K a year.
Thank you, Tajay.
Realistically?
Realistically, seriously, how much do you want to make?
2.2 now.
2.2 mil. All right. What about, what'd you say, Mr. Slade? What is it that how much do you want to make?
Like 50K a year.
50K a year. How much is 50K a year? What is that K? 50,000? How can you want to make that if you don't know how much that is? What is that K? What is the K? 1,000. So you want to make approximately 50,000 a year? Okay. Well, if it's a year, then that's what we talked about when we were doing the whole compound interest thing. No, if it's every year, then what's another word for that? What is it? Annually. So you just said, oh, you got it now?
I got it.
Yes, you got it? Okay, so the whole point is that exponentials are supposed to kind of deal with some money issues. That's probably the biggest real life thing that we can talk about. And we have to figure out in some ways how an exponential might be a little bit different than how you usually study your linear function. So real quick, seriously, if you stand up real quick, honestly, stand up real quick, show me the shape of a linear function. What's that shape? And since you just, that's really good. Since you just talked about rate of change, you can put your arms down. Since you just talked about rate of change, who wants to give me a really good guess, and I'm serious, about the rate of change of a linear function? So like as I move from point to point, every spot, what do you think happens? Are the numbers the same? Are they different? Are they, I don't know, really high, really low here? They might increase by 1, but could they increase by 5? Okay, well from point to point, if I had a line, and I'm here and here, and then I go up again, if this one is 5, what is this next triangle going to be? 5. So if I go from another to another point, it's going to be the same. It's going to be the same. So when we talk about the rate of change on a line, instead of it just being the same, what's another math word possibly that we could use? What is it? Constant. Constant. So it has a constant rate of change. Is that correct? That's what helps us move up and stay in the same space so that we're on the same line. Is everybody kind of with me? Okay, do you remember a little bit of that? Just a little? Okay, so then you had this other shape that you kind of looked at. And this is just a really raw sketch. And you told me that we want to look at an exponential function. That's what I told you we're going to work on today. And we're going to model some of it, possibly. You have to be able to make some really good decisions here. Okay? So the shape, show me, possibly, what the shape with your body of an exponential function could look like. Make it up. What do you think? I got one right here. I don't know if that's right or not. I've got 2 that almost look the same. I've got another one that almost looks like that, but look. So turn around and look. You decide which one you want. Which one do you want, Karen?
I mean, it could go either way.
Oh, it could go either way. Well, let's see. So Sheridan, go ahead and put yours up. You were going that way. Huh? I don't know. That's what we're about to find out. Does that kind of, you've studied, you've seen an exponential?
It's the math.
Which way? Possibly.
It could go this way.
It could go both ways? This way? Okay, so do the shape, everyone, then with your body if you're convinced, either way that you want to go. Okay? So one of your arms is kind of, describe it. Kind of what? Bent? Straight? Like this? The straight line? Bent. What's another word? What is it? It's curved. Little curved. One side is a little curved, and the other one kind of goes into a straight, tapered off type line. Yes? Okay. Very good. And you said that it could go either way, right? What else do you know? Like if I were to put this on the coordinate plane, aside from it bending and all those things, we talked about some parent functions at one point in time. And what do you know about the parent function of an exponential? It won't touch 0. So what is one of your main points that you should know? Like your reference point. What is it?
0, 1.
So your reference point for your exponential function is what again?
0, 1.
0, 1. Very good. And so if I go here, and I draw in some stuff, I'm going to let you sit down in just a second. And I go to 0, 1. Is that in the right spot?
No.
No? Which way do I need to go?
Go up.
Go up? How many spaces? 1?
Right there.
Okay, right there. He's like, duh. Okay. And then you said that one side is supposed to be kind of what? Curved. So which side would you like me to curve?
The right side.
Okay, so this side over here? Yes?
Yes.
So you want me to curve this one? Yes? Which quadrant is this?
1, 1. And the first one?
First quadrant?
Yeah.
First quadrant? Well, what quadrant would this one be in? All right, this
3
one?
and 4.
4. 4. So you want me to curve this side So I can kind of curve it. Curve it. Well, what do you want me to do in quadrant 2?
Straight.
Straight? Am I
Not
supposed
straight
to go-
down.
Not straight down, not straight down. Okay. Straight, so describe it a little bit.
Like
A curve is straight.
like curve it a little bit, but
Uh-huh.
then like
And then
even out
Just
straight,
ride it out.
even out again.
Ride it out. Ride it out along what?
The x-axis.
Okay. Am I supposed to touch the x-axis?
No.
Close to it.
I gotta get close to it.
It don't matter how close.
Doesn't matter, as close as I can get with this red marker, and I ride it out.
That's very cool.
Like that? Yes? So then, this looks pretty good to me. I like. But then you said that there was another one that I could do. There's another one. So describe what would happen in that one possibly.
Start off in the second curve.
Second.
So what piece of it, what would we say that looked like? That's the what part? The elbow. The elbow, I heard it. The elbow. Yeah. So that's the curvy part, the elbow. And I'm going to start off over in, which quadrant did you say? Second quadrant. So I can start off here and I can make this elbow. And then I'm going to do what? Ride out.
Ride it out.
Okay. Sort of like that. So we've got 2 sketches of an exponential function. Yes? They are representing the, which one? Because I could move these around. I could shift them and, slide them over, up, down, left, right, flip them around. But which one is this one? What is this one referred to as? Yeah, but is it the one that I shifted around? Did I move it up, down, left, right? No, I didn't. So give me a word. It doesn't have to be a math word right now. It's the standard one. It's the standard one, which means that it's probably the most common one. Most common. So then now we got to think of some type of word to describe it other than the most common one. I choose the word original. But then what would be the math word that goes with the original function? The which one?
Parent function.
The parent function. So this could possibly be a parent function of an exponential. Yes? All right. So why is it that if it's the parent, though, that's the crazy part. Which one of these really is the parent? Is it the one that goes like this?
The one that goes from left to right.
Left to right. So elbow. Just
Right to left.
Right to left? Okay, you got to tell me. How does that work?
Left
Left
to right.
Left to right. So then, which quadrant am I starting in then? Second quadrant. So is it the red one or the black one?
Black one.
The black one. Okay. And
It could be real.
it could be. But so then, there's 2 different models though. You told me they could go both ways. Do you think, if I'm starting here and I'm moving down, am I increasing or decreasing?
Decrease. But you said that crosses the x-axis, so how can it decrease?
Well, we're talking about the motion because that's a really good question. So she told me to start top left, right? And as I travel along,
Decrease.
what am I doing?
Decrease.
Decreasing?
And then increase.
So, wait a minute. But I only can start from one side.
And it increases.
Well, I don't know. Ask me again,
It's a
Sheridan.
negative and
So, wait a minute. Hold on. Ask me again, Sheridan, and then I'll talk to you.
And it increases because it's decreasing and increasing.
Well, I guess it depends on how you look at this. So my question is, where are you starting? Don't, never mind. It's okay. It's okay. So where am I starting from? Are you starting from
The top.
top? Which quadrant is that? Second quadrant, right? Which way do our eyes usually read? Left to right? Is that what? Is there anybody in here who reads right to left? I mean, you could try, but will it make any sense? Okay, y'all have a seat for me. So when I look at these pictures, yeah. When I look at these pictures right here, I should be looking at it from which way to which way? Which way? I don't know if it's on her face, but it could be right here. Right here. Which way am I supposed to be looking at it? Mr. Tisdale, which way? Left. So I'm starting in quadrant 2. So again, going back to my original question. Do Do you think that this is increasing or decreasing?
I think it's decreasing a while.
Decreasing, so if I'm starting, somebody said top earlier?
It's not stopping, so I say it's increasing.
Okay, but think about what it is, where I'm going, and as I'm traveling. So I start here. What is my finger doing? And even as I ride this one out, you told me to keep continuously getting as close to the y-axis, which means that I'm inching which way? Down, which is comparable to which word? Increasing or decreasing?
Decreasing.
Okay. Almost like it could be something negative, small. What about this one right here? Because am I supposed to start looking at it in quadrant 2? Yes or no?
Yes.
Yes? Okay. Why am I supposed to start looking at quadrant 2?
Because it's left to right.
Which way? Which way did you? Left or right? So I start here, and as I move my finger, and I'm moving, right? What is it doing? Increasing, right? All right. So one of these looks like it's decreasing, and the other one looks like it is increasing. Are we okay with those two words? Kind of, sort of. Where do we start looking at it?
Left to right.
Left to right?
Second one.
Second quadrant, or wherever it looks like it would start from the most left. Anybody have any questions about that yet? No? All right. So one more thing, going back to the rate. I want to compare these two. Is this one, even if I look at the black one, is it going to have the same rate as I move from point to point? So watch. This point to this point, but then from that point. You know how triangles look the same? No? Fast versus slow. Fast versus slow. How fast is that growing? Or better yet, decreasing? Is it very fast? From this point where my finger is to this one?
Oh, no.
What about from this one to this one?
It's faster.
Faster?
Yeah.
Like AT&T? Faster? What about from here?
Like Ricky Bobby fast.
Maybe. Is it a really big drop?
Yeah.
Yeah? Is it the same as this drop though?
No.
So even if I did get it to reduce here, do you think it would reduce to the same thing?
No.
So let me ask you a question. Do you think that an exponential function, yes, go. Do you think that an exponential function has the same, like the constant rate of change, like a linear? Okay, so I want y'all to keep that in mind real quick. Just keep that, hold on to that for me. Can you do that, please? Yes? Okay. So I want you to look at this question. I have something to give you, and you all are going to play around with it a little bit. So remember, I talked to you about making money, right? And sometimes when you want to make money, and I'm serious, when you want to make money, sometimes you can invest your money to make it grow. So you might have more than $50,000, or you might be able to get to that 2.2 million. You think? 50,000, 2.2 million. Because if I invest my money, it is possible that I might be able to make it grow. The idea is how fast can I get it to grow? So on the side that says launch, there's a question that says, which option would you choose? And it's located up on the board as well. So if you haven't gotten your paper yet, you can read it. So left-hand side of the paper. And you physically have to circle which one you think you would want to choose. Option 1 says you can have $1,000 a year for 20 years. $1,000 a year for 20 years. If that's the one that you would like. Or option 2 says you can get $1 for the first year, $2 for the second year. I believe it's really supposed to say, well, yes, $4 for the third, doubling the amount each year for 20 years. So let me make sure that you understand what option 2 is saying. So look, hold on before you pick up the calculator, because I'm going to just kind of let y'all go to work. All right, you ready? Look at option 2 for me real quick so I can make sure that you understand how this kind of goes. All right? So it says $1 for the first year. Is everybody with me? $2 for the second year. So what it did was it took the first year and it did 1 plus 1. It doubled it. Right? So then when I got to the third year, it took the year from before it and it did what to it? Doubled it. So now when I get to the fourth year, how much money would I be making then?
$8.
$8. Very good. Do you understand how that's going to go? Now one more time, just for the record. When I get to the fifth year, Deja, how much do you think I would have? Your name's not Deja. Thank you. Tell me why you agree with him. Doubling what though? 8 from when? From the fourth year. She said fourth year, but you said what year? Previous year. Is everybody okay with that? So make your choice first before you start picking up the calculator. And I just want to walk around and I want to see which one you choose. Oh, and make sure you put your name on your paper, because whatever we don't finish, you're taking home. You don't get to explain anything else other than the choice. Don't convince him. I know you got excited because you want to be right. I love it. But I want to know what you think. That's what I want to know. Did you make your choice? All right. So go ahead and pick up your calculators, and I want you to work with your group. And the next thing that's supposed to happen is it says show how much you would gain at the end of 20 years for option 1. Okay? So however you want to show that, you can draw you a picture, you can type some numbers in the calculator, but whatever you either type in the calculator, whatever you draw, whatever you map out, you need to be able to show it. If you make an equation, I need you to put it in a space. If you don't have enough space, you can pull out some paper. And then the second part says, show how much you would gain at the end of 20 years for option 2. And then I'm going to pull some sticks for you to talk to me about that. How many people have at least started working on option 2 to map out?
I think I finished.
You think you finished?
Yeah.
Okay. How many people at least have option 1 mapped out? Whether it be with numbers that they added, multiplied, drew pictures. What are the two things that you're comparing? You're in, what is it that you're trying to find? How much that you would have at the end of what? So then, do you know how much you have the first year? Okay, so maybe you should write down what you have. Okay? So is that going to, now let me ask you a question, is that going to help you keep up with your thoughts? So if all you want on the paper is $1, what does that $1 represent? So then are you missing some info? Okay. So the idea is for you to do a little bit of, remember you said I'm still thinking, but you got to get your thinking on paper. So then you need to write it down. See, you're going off what you think, trying to plug it into the calculator, as opposed to what you know. Write down what you know. So write down your info. So, Simone, I want you to come talk to the class about your paper. Yeah, you're going to go after her. All right, gentlemen, pause. All right, pause for a second, and she needs your attention. Come on. You get to go up front.
What I did was I started off from the beginning. 1 times 2 is 2. And I kept going until I
So,
reached.
where's your first number? Point. Because it kind of looks, okay. So stand on this side. And then, can y'all see that? Yes? Yes? Okay. So talk about that for me. Go ahead.
So I did 1 times 2, which I got 2. Did 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. 128 times 2, 256.
Okay, stop for just a second. I want you to take the marker and I want you to go put at least that first row up there. Your calculations, okay? Just what you just said, okay? Here. Yes, I do want you to come up. All right. Go ahead.
So I took the dollar that they said that you was gonna get for the first year, and I'll multiply it by 2, and I'll keep pulling the number out and multiply by 2 each year until I got to this. This was the wrong number, I think. So
Okay.
it's right here. So I put 20. That was 21. This is 20.
Okay.
So I got
So your answer is how much?
52,428.
Okay, so change your comma. Okay. Change your comma. Do Samana Care have the same method for option 2? Yes? Yes? Okay. Do you think that there's another way that we might have been able to find that number after we look at the pattern? That's what I want you to be looking for. Or that's what I'd like for you to look for. So if that is indeed truly the right number, what we're trying to figure out is there another pattern or something that you know about that would help you find this a lot faster? Okay, so Darrell right now is thinking you'd have to make an equation. Because if I asked you how much you would have after 100 years, like let's say you left money behind for somebody, then you wouldn't want to sit here and do this 100 different times, would you? No. Okay? So I want you to be thinking about what it is that they have in common. So say this number for me again so that you can tell me how much you think we have after 20 years.
524,288.
Very good. Dollars. $524,288. Okay? So I want the both of you to go up. And while we're doing that, so Taquan, you go. Good job, Kira. Thank you. And thank you, Simone. Because I'm going to ask a question because yours wasn't on the paper and hers is, so I'm going to put them back up there in just a second. Okay? And this is going to have to do, remember what you're supposed to be thinking. Something that they possibly have in common that you might be able to use to write you an equation. Okay? So you want to talk to me about what you think you did? Go ahead. Speak up.
Well, the first year I started off with 1, and I timed by 2, and I just kept going by 2, by 2, by 2, every time until I got to 20.
Okay. So, do you notice something about his paper, though?
He made a table.
He made a what?
A table.
He made a table. He made a table. So sometimes when we have a table, it would, I guess, infer that we have some different types of values that go with that equation that Darrell is talking about, because in equations, what variables do we usually have? Come on. What? Come on. I heard you. What kind of variables do we have in equations? X's and Y's maybe? So we need to be thinking about some type of equation that we can make for this particular problem, right? Using what they have in common, and now what we have is a table that we might be able to do that with. So in this first table, or in this first column, what would this represent in words? What does this represent? Nah, that's not a word. X is a variable. So it could be variable X, but what would X still represent? Words. Come on. The what?
The year.
The year. Is that, look at it. Come on. So this is the what? First year. This is going to be the... All right. And if this is indeed X, if it truly is X, then that means that X is going to have to be, how would I define that? X is going to be, what about the years? Not just years.
The number of years.
Number of years, amount of years, the year that I'm on. Do you understand what I'm saying? Yes? So right now, we are doing this. And that is when we tell what the variable actually represents in words. This is one of the things that you did not like about your word problems. But sometimes if you define a variable and you can tell what it is that you're trying to find or what you have in words, it makes a lot more sense. Are we working with years here? Yes or no? Yes. So one of the things that's ever changing, are we still on the same year every year when we're looking at the money? No, the years are doing what?
Going up.
They're changing and they are going up. They are increasing. So X is increasing. Do you have that? Yes? And what did we say that that would represent again?
The number of years.
Number of years. Are we okay with that? So let's look back at his table again. And on his table, if this column would be X, then this one is probably going to be what? Y, possibly. Because as X changes, then it's going to affect how Y changes. That's good. How Y changes. X is going up, so what else is, well, what is Y doing? Going up. Do you understand that? Yes? Okay. So what, if we wanted to define Y, what would we define it with? An amount?
Amount of money.
The amount of money. The amount of money. Got it? So, this is the number of years. Of course, in years. Because this is my label. This is my money.
The amount.
How do I label it, though?
The amount money double.
Yeah, but I can say money, but I guess what I'm saying to you is, you know, when you measure length, you might say centimeters. You might say inches. So when you do money, what do you label it with?
Cash.
Yeah, you don't say, when you go to the register, you do not say, the person doesn't say, can I get five cash?
The amount.
They don't say,
They used to.
no, they don't say 5 cash. They say 5 what?
Dollars.
So what is your unit on your money? Dollars. Do you understand that? Do you understand what I just asked you? So you need all of this. You need all of this. So then if I'm getting ready to make me a graph, sketch it, because that's really sloppy, right? Which axis is this one?
The money. Oh,
This one is Y, but I still have to define what it is.
The money.
The money, this is my money.
Money and dollars.
Money in dollars. Dollar bills. Okay? And this axis is which one? Which axis? Now be careful. Which one? X. And how did I define that one?
Number of years.
Number of years. And of course that's in years. That can happen sometimes. Okay? Maybe. But this time not. Because really we're not talking about which year. So leap year doesn't matter. We're talking about which year, I guess the amount of years that have gone by. Does that make sense? So do y'all understand his question? He's asking about a leap year, which is perfectly valid. But it doesn't matter if we add in a leap year because we just have another year that we've added on. So the number of years passed that I've been collecting this month. All right, we good? Because I want to kind of close this out. We okay? You did good. You did good. You did good. You did good. Do you understand what's going on? How many people chose option 1? Toya, you all right? You good now? Yes? A little bit better? And you found your mistake? Okay. So, wait, option 1, be honest. Because I need Stephanie to speak. She's going to kind of close us out. She doesn't know it yet, but she is. How many people chose option 1? Be honest, Tisdale.
I did, but I ain't do
I
that.
think convinced you chose.
Oh.
Right. Your choice. That's very good, Kiera. Thank you.
That talking is stupid.
That,
You let him.
your talk game might be a little ridiculous. I might have to give you credit for that. All the way up. Option 1. Hands up. So upon first glance, you felt like you would want to have $1,000 a year, correct? Because off the top, off the gate, I definitely heard you all say, oh, that's how much a year? I mean, after 20 years, how much money do I have? $20,000. Well, $20,000 is nice when it's free.
Yeah.
So $1,000, and that's really, I believe, with just off the top of his head, he's just like, yeah, $1,000 a year, 20 years go by, I got $20,000. Yes? But you had to think a little bit harder when you started talking about this money doing what? Doubling. We just keep using that word, doubling. Doubling. So, doubling is nice, but guess what word is even nicer than doubling? Oh, yeah. Quadrupling. And all of those things could happen. You could double your money, you could triple your money, you could double it. And the one thing that all of their numbers had in common was that double. The double. So how, Stephanie, she said, this was her statement. I knew the second one was going to be more, but I chose the first one. How did that happen?
Well, it's because the first option, it already like starts with a big number. And the second option takes like a lot of time, and it starts with $1 and then $2. And
Makes your sister virtue.
So now we come up with that whole thing. Taekwon says that's really good. The first one starts with a big number, and that's the first thing that you see, yes? But then the other one, it starts off kind of, remember those two words that I gave you? Fast and slow. Fast and slow. The first one starts off really what?
Fast.
Nah, the first one starts off really fast. Does the rate that it goes at change though?
No, not at all.
Nah, it's what? What's that math word again? It's what?
Constant.
Constant. You with me, Tajay? Yeah. But the second one starts off with a really small number. That was good. And then it goes kind of slow.
Well,
It is slow, $1.
It picks up after a while. though.
It does. Because think about it. If let me see. I did say I was going to use your paper, so come. Let me see.
It would sort of be like,
If we start off really what again? Slow. Slow still. Slow. Is this kind of slow still?
yeah.
Yes? $8. Y'all like, that's still McDonald's. $16, I might be going to Chili's.
It's slow until.
It's slow until. That's what I'm looking for. Here it is. It's slow until
I
what?
would say 11.
To where?
Here.
All right, so I'll slide it over a little bit so I can cover up her first side. Can I bend your paper, please? So right in here, and be careful because his 11 lines up right there. So he says right up in there around 11. 11 years have gone by. I need you focused, right? 11 years have gone by. And what happens, James? Starts increasing? But increasing how? Yeah, but how does that have an effect? Now remember, think about the words. What words am I using?
Double.
Okay, so we got the doubling, and it's doubling. It doubled in the beginning. But what was that rate doing again? It was kind of slow, and then it did what, James? It picked up. But then, when did it really pick up?
Like the 11th year.
Around the 11th year?
Because $512 is a lot.
Say that again,
Around
Mr.
10,
Tuesday?
Yeah, around 10, between. There you go, between.
So between 11 and 10 and 11?
Yeah.
So you went from $512 to almost having, again, double. It didn't seem like double was a lot when you did $1 and $1. But 500 plus another, 512 plus another 512 really sets you off. Yes? Yeah? Shopping mode? I could get me a couple of purses. I have a vice with purses. Okay, so but watch. So here's the thing. They just said, say it again, Foster.
They can $1,000 for loan use that you could get in 1 year.
So I'm going to help because I know you don't really speak really loudly. She said it took 11 years to get to your first $1,000 because these are all the things that you're supposed to see. It took 11 years to make you that $1,000 that you got in your first year. Right? But some people feel like it might be worth it because you said something early. Patience. That's what, and some people believe that. So it's all about how you want to invest your money. Yes? No? Maybe? Okay, so now let's close this out with an exponential then. Is the rate here? No. Is the rate going to be constant even if you go from here to here? No. Which is what you thought at first, right? That's fair. It's fair. Okay, class. Remember that we have some things that we talked about today as far as the exponentials were concerned. We're getting ready to go ahead and close out class because the bell's going to be ringing in a few minutes. So I just want to make sure that we refocus and that you remember that today you were supposed to be looking at interpreting the parts of the exponential function, which are some of the things that we definitely talked about. We did talk about the table of values and some of the verbal descriptions. We will be talking about domain and range tomorrow, and we'll be continuing on with the exponential in the context of the equation. So make sure that you get your work done, and I will see y'all tomorrow.